Revision on Junior Form topic, Unit 3, Factorizations. In this video, I would like to have a short review with you related to one important concept, which is called factorizations. You have learned several methods in S2 and S3 for the factorizations. Method 1 is taking out common factor. I want you to remember, no matter what question you want to finish, step 1, you need to find the common factor first. If you cannot find any common factor, you can jump to the method 2, method 3, and method 4. For example, in this case, 5b minus 4ab. You can see there are common factor b. You can take it out. When you take it out, the first term remains 5. The second term remains negative a. Sometimes, if we have 3 terms, maybe you will think about, can we use the factor method or an identity method? But remember, you also need to consider, do they have any common factor? We can find y is the common factor. You need to take it out first. After that, remain this part. You need to think about, do we have another method, or can we factorize it completely? If we cannot, then you can leave it. This is your final answer. The second method is called factorization by grouping. Factorization by grouping. I want to pinpoint what is the aims of this method. If you want to factorize it, you cannot find any common factor. But you can find the common factor for the first term and for the first 2 terms and the last 2 terms, which is x, and you can find y. Remember, when we need to apply the factorization by grouping is after taking out the partly common factor, x and y. After taking it out, you can find the common factor of these 2 terms. Then in this case, you need to use the factorization by grouping. I find some of the students try to factorize this term. They will consider, oh, we have 3 terms here, and then we have we have the common factor of the first 2 terms. You try to take it out. But these questions, you cannot use this method because after you take it out, x, you cannot find any common factor of these 2 terms. So this is not the correct method. 呢度咧，我想補充一句 ，factorization by grouping 係因為當你抽咗 group 完抽咗個 x 抽咗個 y 出嚟，你發現呢兩個 terms 係有 common factor，所以呢個 factorization by grouping 先係 meaningful。如果你抽完出嚟，發現佢冇 common factor，咁即係代表呢個方法係錯，你應該要用另一個方法去 factorize。咁你話呢3個 term 佢又冇 common factor 又冇 grouping， 所以就會跌落第3、第4個方法 ，which is factorization by identity. Can you see this is one of your identity? If x squared plus 2xy plus y squared, then you can apply the identity. A squared plus 2ab plus b squared, which is equal to a plus b all squared. So this is the final answer. Sometimes you cannot observe the identity directly. You need to change it. The first term, you cannot change it. This is a squared. And then this is 16y squared. You need to change to b squared. That means the whole term all squared. So this is 4y all squared. You need to check this is 2ab or not. If no, you need to jump to the method 4. Factorizations by using box method or quartz method. So you need to check. If I rephrase the second term as 2x and 4y, and then multiply them together. Can you see this is equal to negative xy? That means they are equal. So I can change the form to a square minus 2ab plus b square. 我多數會做咗頭尾，睇下中間可唔可以寫翻做 2ab，check check 一唔一樣。如果一樣，即係代表 this is an identity. So I know a square minus 2ab plus b square is equal to a minus b all square. This method is called factorization by using identity. The last one, I don't know what method you learned to factorize this method. I only want to introduce one method, which is called factorization by using box method. You need to draw this box first. I know when we expand it, this is equal to 3x squared, so I will write down 3x squared here. And then negative 2, I will write down in these positions. You need to consider what number of these two boxes we need to put it down. Okay, which term I need to put it down. So you need to think about this question in this way. Just like an IQ. First of all, you need to multiply this 2. This is negative 6. And then the middle term is equal to negative 1. Think about two numbers. Multiply them together is equal to negative 6. Add them together is equal to negative 1. How come? 嗱，呢度咧，我想講我點樣諗嘅。box method 最緊要諗呢兩粒。咁我諗嘅嘢就係先將呢兩粒相乘咗先，負6嚟嘅。咁中間嗰個 term 咧就係負1。咁你要諗一樣嘢啫，就係有邊兩個數相乘要出負6，相加要係負1。咁相乘要係負6咧，其實唔係好多選擇嘅啫。咁你可以逐個 list 啦，或者你心裏面已經有答案啦。相乘要負6就即係負1、負6啦，負1 6啦，或者負6 1啦，負3 2或者負2 3，得4組數可以做到嘅啫。相乘要係負6，咁又一定要一個正一個負啦。咁啊要相加要係負1，咁好明顯啦，得呢組啫。呢組數係相乘負6，相加負1。So you need to write down negative 3x here and 2x here。因為呢個係負3，呢個2，咁所以我寫落呢度啦。Then you can take out the common factor of these two terms. When you take out the common factor, it's equal to x. If you remember this box method, you know these two terms multiply them together is equal to this one. So this is 3x. These two terms multiply them together is equal to this term. So this is negative 1. If this term is negative 1, this term is 2. So after that, you can factorize. This is x minus 1 and 3x plus 2. 嗱，我唔知咧，你上年係咪咁樣讀？咁但係咧，我嘅 box method 咧會係咁樣做嘅。咁我咧呢度咧再重新講一次，我究竟諗過啲乜？我咧先會諗咧呢兩粒相乘會係負6，呢個 term 咧係負1。咁咧你要諗嘅嘢咧就係咧要諗兩組數，相乘要係負6，相加要係負1。咁你可以咧從相乘開始諗，乘負6咧可以係負1 6、負6 1、負3 2、負2 3。而要做到相加要係負1得呢一組啫。咁你記住呢個啦。咁我哋開始畫個 box， 將個 3x 試擺呢度，負2咧最撚尾 last term 咧就擺呢度。我要呢兩個加埋咧應該要係負1嚟嘅。咁頭先啦，呢兩粒點諗㗎？就係用呢個方法諗。諗晒呢4個啦，開始抽 common factor， 將咧呢兩組數抽 common factor 出嚟就係 x 啦。 咁當你抽完一個咧，就差唔多寫晒啦。個原因點解咧？因為你知道呢兩個雙乘要出呢粒噶嘛，喺個 box method 裏面。咁所以呢個 x 嘅時候，呢個係 3x 咯。呢兩個雙乘又要出呢粒嘅，所以如果呢個係 3x，呢個就要負1啦。同樣道理咧，呢個要 2x，咁如果呢個係 x 咧，呢個就2啦。如果呢個係2咧，呢兩粒雙乘要出呢粒，所以呢個係負1。咁所以咧個 factorization 就 x 減1同埋 3x 加2啦。咁呢個方法咧係我覺得最好嘅，亦係最快去做個 factorization。咁我就不嬲都唔會用 cross method 嘅。咁我哋咧會用幾條題目咧幫大家溫下書。For example, question 4. Maybe you can pause the video, okay, and then check, do it first, and then check the answer. Question 4. If you see two terms, remember step 1. Do we have any common factor? No. So you can see, can we factorization by grouping? We have two terms only, so you cannot use factorization of grouping by grouping. Okay, it is an identity. I find this is an identity. So I change to 2m all square minus 5n all square. So a square minus b square is equal to a minus b times a plus b. So finish. Part B. Typically, you can find this term, the term in part A in part B, okay? So that you can copy down the answer. You can get the first mark. So in the second part, you need to factorization by grouping. Group these two terms and try to do the factorization first, and then factorize the second term. So take out 3, remain 2m minus 5n. Now we have common factor. This term is called c. c times a plus 3 times c. So you can take out c. For the first term, take it out. 2m minus 5n remain 2m plus 5n. The second part remain 3. So this is your final answer. Let's see one more example. Question 6. 3 terms. Maybe some of you will try to use the factorization by identity or box method. But remember, step 1, can you find any common factor? Yes. So you need to take out x squared first. For the first term, remain x. Second term, remain y. The last term, remain 7. Do we need to factorize it? No, because we cannot factorize it by using identity and grouping. This is linear. So this is your final answer. Maybe you can change to the small bracket first. Part B, typical. You can see part A in part B. So use part A directly. X squared, x plus y minus 7. The second part is negative x minus y plus 7. Can you see common factor? No, because this is positive x plus y minus 7, but this is negative plus 7. So you can take out negative to find the common factor. So take out negative. Negative change to the positive, so positive change to the negative. Now I can find the common factor. Now, so you can take it out. Finish? Not yet, because I find identity. A squared minus b squared. So you need to factorize it completely by using identity. The last question I want to demonstrate is question DSC 2014. We have 3 terms. We cannot find any common factor, so maybe identity. But can you see 3 is not a perfect number, so cannot change to b squared, so must be box method. This thinking is very important. So negative 3 times 1 is equal to negative 3, and then the middle term is equal to negative 2. You need to consider a pair of numbers, multiply them together is equal to negative 3, and add them together is equal to negative 2. Multiply them together is equal to negative 3, two choices, negative 3 and 1, and negative 1 and 3. Add them together is equal to negative 2, so must be this one. So you can construct the box. A squared, negative 3, negative 3a, and 1a. Because this is 1, so this is 1a. Negative 3, so this is negative 3a. So take out common factor. Take it out, take out a. So for the first, it's a, and then you can fill in all, because multiply them together is equal to a squared. So a times a is equal to, so this is 1. If this is a, that means this is negative 3. So this is equal to a minus 3, and then a plus 1. Part B, can you see? Same there. I'm here, so you can write down the answer. For the first two terms, maybe you can leave it. And I can find the common factor of the first two terms, so you can take out b squared, remain a plus 1. After the factorization by grouping, you can find the common factor a plus 1, so you can take out a plus 1. For the first term, remain b squared. The second term remain a minus 3. And normally I will add the bracket because sometimes this is negative. You need to cancel the bracket and multiply the negative. But this time, okay, this is positive. So I will write one more step. So remember, when you want to do the factorizations, step 1 must be taking out the common factor. Find the common factor. If you do not have common factor, you cannot find any common factor, try to use the vector method by grouping. If you see there are 3 terms here, that means no grouping. You cannot use the factorization by grouping. Then think about identity or box method. After factorize it, and then remember in second part, you need to use the result in part A, and then by using the factorization of grouping, and then factorize completely. Remember, sometimes you also, after taking out the common factor, you also need to think about, can we find any common factor for the remaining part? So don't leave it. So think about it. Hope that after watching this video, you have a more concrete concept of factorizations. Remember, this is one of the typical questions in session A1, in paper 1, and also in paper 2 MC questions.